Hi, everyone. Welcome to lesson 1.8, where we're going to review the types of solutions in linear systems. So we're going to investigate the number of solutions in a linear system. First, graph each linear system on the grid provided using the slope and y-intercept method. We're going to complete this table for each system and determine how many solutions there are in each system. So the first we're going to focus on is A here. And I'm going to put them into this first part of the grid. So in y equals 2x plus 1, the slope is given, it's 2, and the y-intercept, b, is 1. Now the second equation needs a little bit of manipulation. This one is 8x minus 4y equals 20. If we're going to solve for y, we'll move that 8x over, so I'll have negative 4y equals negative 8x plus 20, and then I'll have to divide through by negative 4. This new equation is now in slope-intercept form. Negative 8 divided by negative 4 will give me positive 2x, and then 20 divided by negative 4 is going to give me negative 5. So now I can see that my slope is 2, and my y-intercept, b, is equal to 5. So I'm going to zoom my graph in as much as I can here. And for the first one, my y-intercept is 1. So I'm going to put a point here at 1. And my slope is 2. So I start from my y-intercept and I go up 2 and over 1. I'll do it a couple of times so I get a couple of points. And then do my best here to draw a straight line between them. Okay. And then we'll start with the other line, which is 5 is the y-intercept. So I'll put a dot right there. And this one, the slope is also 2. So I'll go up 2 over 1. And then I'm going to work my way backwards. I'm going to go over 1, down 2. Over 1, down 2. And again, just to get a couple of points so that when I draw my line in, it's somewhat straight. So here, if we can see, we have two parallel lines. So the lines have the same slope, different. I'll put the word different here. Y-intercepts. So there are no solutions here, because remember, a solution is where two lines cross, and these lines are parallel. So they will not cross. So this is a situation where we have no solutions. Okay, let's take a look at my next example. We have b, x minus y equals 1, and 3x plus y equals 9. I'm going to put those both into slope-intercept form, starting with x minus y equals 1. Negative y equals negative x plus 1. Divide through by a negative 1. Clear the negative signs. And I'll have y is equal to x minus 1. So my slope for the first one is 1. And my y-intercept is negative 1. Taking a look at the second one, I have 3x plus y equals 9. So I'm just going to move the 3x over, and I'll have y is equal to a negative 3x plus 9. My slope here then is negative 3, and the y-intercept for this one is 9. I'll go over to my graph. I'll zoom in here. See how close I can get these. So for the first one, the intercept is negative 1, and the slope is 1. So up 1 over 1, up 1 over 1, up 1 over 1. Right, so there's my first line. And for the next one, this y-intercept is 9, so that takes us off of our graph a little, like 6, 7. Let's try and ballpark it here. And then the slope is -3, so it come down 3 over 1, down 3 over 1, 1, 2, down 3 over 1. See if I can put these dots together. Not too bad. So we can see that in this system of equations, these two lines actually cross each other. So for this system, we would say that the lines have different slopes, and there is one solution. So there is one point at which these two lines cross. Let's go on to the next. And the equations that we were using here was 4x minus 10y equals 20. Zoom in a little bit. Negative 10y equals negative 4x plus 20. And I'm going to divide through by negative 10. So y here is equal to negative 4 divided by negative 10 is going to give me 2 over 5x. And then 20 divided by negative 10 is going to give me negative 2. So my slope here for this first equation is 2 over 5, and the y-intercept is negative 2. Taking a look at the second equation, this was 2x minus 5y equals 10. Moving the 2x over, I will have negative 5y is equal to negative 2x plus 10. Divide through by negative 5. And I'll have y is equal to 2 over 5 minus 2. So my slope here is 2 over 5, and my y-intercept here is negative 2. So if I go over to the graph again, our intercept is negative 2, so we'll start with that. And our slope is 2 over 5, so up 2 over 5. And go backwards. All right. So here's the line of the first one, but if you notice, the equation, the second equation, also has the same slope and the same y-intercept. So basically, that second line would lie right on top of this first line. In this situation, the lines have the same slope and the same y-intercepts. We here say that there are infinite solutions, and the lines are actually the same. Good. So what would happen if you tried to solve a linear system using substitution that had no solution or infinitely many solutions? Let's take a look at what would happen. So in our first example, we have 2x plus 4y is equal to x plus 2y equals 5. So the first one I'm going to call my first equation. I'm going to rearrange the second one so that I have x equals negative 2y plus 5. And that'll be my second equation. And I'm going to sub the second equation into the first equation. All right, so 2 times, instead of writing x, we'll write 2y plus 5 plus 4y equals 8. Simplifying, we get negative 4y plus 10 plus 4y equals 8. I have a negative 4y here. That's actually going to cancel with a positive 4y. So what I end up is I get 10 on the left side and I get 8. But 10 is not equal to 8. And so therefore, because this is not true, so this is not true. So there are no solutions. And these lines would be parallel. So let's try the second one. We'll solve again by substitution. And at the top, 6x minus 3y equals 12. I'm going to call that my equation 1. And then y is equal to 2x minus 4 is my second equation. So I'm going to sub my second equation into my first. And we will have 6x minus 3 times 2x minus 4 equals 12. Simplifying, I'll have 6x minus 6x plus 12 equals 12. In this case, 6x minus 6x, those are going to cancel. And here I'm left with 12 on the left and 12 on the right. In this case, 12 is always equal to 12. So this is always true. So here, there are infinitely many solutions. And these lines are actually the same. Great, so we're done with that quick lesson on 1.8. You'll see in the Google Classroom that we have an assessment that you'll do on Quilgo. So good luck with that. Let me know if you have any questions.